with the chemistry, chapter 1, it's atomic structure and radioactivity. So these are the sources from this the topics has been taken in this chapter, right? So we'll starting up. The idea of divisibility of matter was considered long back in India. Around 500 BC, an Indian philosopher, Maharishi Kannan, talked about the indivisible particle and named it a Parmanu. Another Greek philosopher, Democritus, called these indivisible particles atom. So इंडियन के वो जो थे उन्होंने क्या महर्षि कनन ने क्या कहा था परमाणु, और जो ग्रीक फिलोसफर थे डेमोक्रिटस उन्होंने इस इंडिविजिबल पार्टिकल्स को क्या नेम दिया था एटम्स. द वर्ड एटम्स ओरिजिनेटेड फ्रॉम द ग्रीक वर्ड एटॉमी विच मीन्स नॉन डिविजिबल, जो आगे ब्रेक नहीं हो सकता है. By the end of 18th century, scientists had found out the difference between elements and compounds. They became interested in finding how and why elements combine and what happened when they combine. So we'll start with the theories now. It's Dalton atomic theory. In the year 1808, John Dalton presented the atomic theory of matter, which is called Dalton's atomic theory. According to this theory, all matters, whether an element, a compound or a mixture, is composed of small particles called atom. कोई भी मैटर हो, चाहे वो एलिमेंट हो, कंपाउंड हो, मिक्सचर हो, सब जो है स्मॉल एटम्स में होते हैं. The main postulates of Dalton's atomic theory are as follows. Every matter is made up of very small particles called atoms, which undergo chemical reactions. Atoms are indivisible particles which can neither be created nor destroyed in chemical reaction. Atoms of given elements are identical in masses as well as in chemical properties. Atoms of different elements have different masses and chemical properties. Atoms combine in ratio of small whole numbers to form compounds. The relative numbers and kinds of atoms are constant in a given compound, right? So now we'll study what is subatomic particles. In starting of 20th century, it was proved through the experiments of research workers like J.J. Thomson, Rutherford, Niels Bohr, J. Chadwick, etc. that an atom is made up of three fundamental particles called electron, proton and neutron. So electron किससे बनता है? Electron, proton और neutron से. नेक्स्ट इज डिस्कवरी ऑफ इलेक्ट्रॉन. इलेक्ट्रॉन को कैसे रिप्रेजेंट करते हैं? इस वे से हम इलेक्ट्रॉन को रिप्रेजेंट करते हैं. इन 1850s many scientists, mainly Faraday, began to study electrical discharge in partial evacuated tubes known as cathode ray discharge tubes. In this experiment, when sufficiently high voltage and low pressure is maintained, a stream of particle is originated from negative electrode, which is known as cathode, to positive electrode, which is known as anode. These originated particles were called cathode rays or cathode ray particles. These rays themselves are not visible, but their behavior can be observed with the help of fluorescent or phosphorescent materials which glow when they hit by them. In the absence of electrical or magnetic field, these rays travel in straight line. In the presence of electrical or magnetic field, these rays behave same as the negatively charged particles, suggesting that the cathode ray consists of negatively charged particles called electrons. In 1897, the British physicist J.J. Thomson identified the electron as one of the subatomic particles. So in 1897, the electron was identified, right? Now we'll study the charge on electron. What is the charge on electron? The charge on electron is minus 1.602 into 10 to the power minus 19 coulomb, which was determined by R.A. Millikan through oil drop method. Mass of electron, what is the mass of electron? 9.11 into 10 to the power minus 31 kg was determined by J.J. Thomson. The mass of electron is considered to be negligible and its charge is minus 1. Charge to mass ratio, the charge to mass ratio is 1.76 into 10th power 8 coulomb per gram, which is independent of the nature of gas and electrode used. Next is discovery of proton. So proton is represented in this way, right? Before the discovery of electrons, E. Goldstein in 1886 discovered the presence of new radiation known as Canal rays. These rays were positively charged radiations, which ultimately led to the discovery of another subatomic particle. These subatomic particles had a charge equal in magnitude but opposite in sign to that of electron. It was given the name proton by Rutherford. So this was identified by, proton was identified by Rutherford in 1919. These also travel in straight line and get deflected in electrical and magnetic field. So the mass of proton is 1.67 into 10 to the minus 27 kg. Charge is in a positive plus 1.0602 into 10 to the minus 19 coulomb. Their charge to mass ratio depend upon the nature and taken in the discharge tube. In case of electron, it was independent of nature, right? But in the case of protons, they are dependent on the nature of gas. Now comes the discovery of neutrons. When fast moving alpha particles collides on beryllium sheet, electrically neutral particles are emitted whose mass is slightly greater than the mass of protons. These are named neutrons. Chadwick discovered these particles in year 1932. So the neutrons were discovered by Chadwick. Protons were discovered by Rutherford and electrons were discovered by J.J. Thomson. Right? So here you can have a look. It's a table in which it's given electron, proton and neutron and all the charges, amount of charge, mass, founder, presence, everything is given in the same table, right? This is even one more table which is given here. The charge, mass and founders are given here. You can just take a screenshot for this if you want to know this. So we're coming up with the next topic, which is the atomic models. Following atomic models were proposed to explain the distribution of charged particles in an atom. First one is the Thomson model. It was proposed by J.J. Thomson. As the name implies, Thomson, it was given by the J.J. Thomson in 1898. This model was similar to Christmas pudding or watermelon model. They can ask the name, what the other name for this model, right? In this model, atom is considered as sphere in which positively charged particles are uniformly distributed and negatively charged particles are embedded in. Negatively charged particles like this, ये इसमें है, positively charged ये uniformly distributed है. Mass of atom is assumed to be uniformly distributed throughout the atom. What were the limitations of Thomson model? It could not explain the stability of an atom. It could not explain the experiment results of other scientists such as Rutherford, as there is no nucleus in the atomic model proposed by Thomson. जो थॉमस का मॉडल था उसमें न्यूक्लियस कहीं उन्होंने डिफाइन ही नहीं किया था, तो इसकी ये लिमिटेशंस थी. सो नाउ कम्स द रदरफोर्ड मॉडल. It was proposed by Ernest Rutherford and his students Hans Geiger and Ernest Marx. This model was based on alpha particles, doubly charged helium ions having a mass of 4U, scattering experiments of thin foil of gold medals 1000 atoms thick. On the basis of his experiment, Rutherford put forward the nuclear model of atom having following features. Now we'll see the features which Rutherford has proposed. There is a positively charged, highly dense center in an atom called nucleus. उसने कहा था एक न्यूक्लियस है जो पूरा ये पॉजिटिवली चार्ज्ड है, बहुत सारे इसमें पॉजिटिवली चार्ज्ड है. नियरली द होल मास ऑफ एटम रिसाइड्स इन न्यूक्लियस. पूरा मास इसी में न्यूक्लियस में रिसाइड होता है. इलेक्ट्रॉन्स रिजॉल्व अराउंड द न्यूक्लियस with very high speed in circular path called orbits. इसमें ये इलेक्ट्रॉन्स ये रिवॉल्व करते रहते हैं. Electrons and nucleus are held together by electrostatic forces of attraction. Size of nucleus is very small as compared to the size of atom. Now comes the limitations of Rutherford. It could not explain the stability. इसमें भी एक limitations थी कि ये भी atom की stability को explain नहीं कर पाया था. Same ये जो limitations थी ये हमारी Thomson model में भी थी. When charged electrons are moving under the attractive forces of positively charged nucleus. During acceleration, charged particles would radiate energy. Thus, the revolving electrons would lose energy and finally fall into the nucleus. Next is the Bohr's model of an atom. To overcome objections raised against Rutherford's model of an atom, Niels Bohr put forward the following postulates about the model of an atom. Electrons can only revolve in certain special orbits, which are called discrete orbits of electrons. When electrons revolve in these discrete orbits, the energy is radiated. The orbit or shells are called energy levels. Orbits को और क्या कहते हैं? Shells. These orbits or shells are represented by K, L, M, N or by the number N, 1, 2, 3, 4 and so on. Right? So if you like this video, please like, share and subscribe my channel. I'll just continue this chapter in my next lecture.